An example that I often use when I'm teaching this is the idea of a universal remote. So think about a universal remote. What does it do? Universal remote is this device that sits in your hand, and it talks to different kinds of TVs. TVs, VCRs, DVD players, cable boxes, blah, blah, blah. It has a predefined interface. It has a predefined set of buttons that you interface with. Volume up, volume down, channel down, number buttons, pause, play, stop, record, whatever. Those buttons are predefined on that remote. It's the responsibility of the TV manufacturer, let's say. This may not be a true case, but let's just follow it. For them to write the software that gets loaded into that remote. So, how does that work, and how do you make that all kind of work together? So you start out by creating an interface. Let's say it's iTV remote. And in this remote, we have a set of methods. We have void power toggle, void channel up, void channel down, int volume up, int volume down. And let's just start with those. Now to implement that, let's say that we're creating it for, let's see, this is an LG TV remote. Okay, that's our class. So it's going to implement iTV remote. And just for simplicity, we'll just do some console write lines. And we'll say toggle power. Channel up. Channel up 1. Channel down 1. Volume up 1. Volume down 1. Return -1. Return 1. Okay, so this is my implementation for this remote. I'm going to go ahead and add one more. I'm going to add a property here of string name so that we know what kind of remote it is. So now I have to come back and implement that in my LG TV remote. Prop string name. Return LG TV. So then coming back here, we'll create iTV remote. And we'll say the remote equals a new LG TV remote. Okay. And I'm going to have this method called test remote. I'm going to pass in my remote. Now this method test remote, I'm going to say public void test remote iTV remote. And then it's just going to go through all those tests. So say remote.toggle power toggle, remote.channel up, remote.channel down, remote.volume down, remote.volume up. And then we'll do a console write line of remote.name. has to be static. So that test basically tests our remote. It calls each one of those methods, those interface methods, and gets the appropriate output. So in that case, going back to the point of, can we use a base class? Well, as the vendor, you don't really want a base class because you want to have total control over your implementation of how your remote works. So let's say you're Sony. Actually, let's just say it's a Sony remote. Just to kind of hurry things along, I'll just grab these implementations and copy them. So if I come up here now and I swap this out for a new Sony remote and run, oh, I didn't make this. That's right. Oh, I didn't implement my interface. So then we have the Sony remote. Okay, so that's where we are. What if we decide we're not just going to provide TV functionality, but we also want to enable to have like DVD, VCR type functionality? We can write another interface as the remote manufacturer. And we can say iDVD remote. So what do you have in this case now? You have play, pause, stop. There's obviously more, but you get the drift. And then we'll still have string name with a get. Now the LG remote doesn't implement those features, but the Sony remote does. So we can say comma I DVD remote, and then we implement this interface, which gives us some additional methods to implement. So we can say play DVD. Pause DVD. Stop DVD. That sound makes me think of the snow monster from Rudolph and the Red-Nosed Reindeer. So we have this remote, which maybe we should now label a TV remote. But we can also create another one that's iDVD remote. And we can actually, let's see how we want to do this. Well, let's say this is a Sony remote, R equals new Sony remote, and then we can go back and kind of do this idea of R, but then we can say DVD remote, so DVD remote equals R as well. So we're now implementing two interfaces. We have two different variable types, one for DVD remote, one for TV remote. And then we can say test remote, but we don't have a TV remote, so this will be test DVD remote, because those types are technically different. So then we'll implement a method that does the same idea. So it'll call DVD remote.name. We'll do another 40-line deal. And then we'll do DVD remote.play, DVD remote.pause, DVD remote.stop. F6, F5, and black for formatting. We now have the Sony remote doing the TV functionality and the DVD functionality. If we flip back and use the LG remote, it won't work. So if we try to run this, we'll get a compiler error. Because right here, we can't take our remote and put it inside and make it a DVD remote. Now, I'm going to do something that's kind of a little beyond where we've gone so far in this course. But I'm going to create this method. And I want to show you this idea of dynamic loading. So everything I'm doing is static, so you're kind of like, what's the big deal? Well, the idea is, so we go back to that concept of a plug-in phone. Well, what if you can go in and on the fly choose which remote you want? You don't pre-code it, so you don't really know what remote you have to choose from, but you just get this list. It comes up on the screen. It says, what kind of TV do you have? What kind of remote do you want? LG or Sony? You pick it, and then by choosing that, your program is actually intelligent enough to say, okay, I'm going to go dynamically create an instance of this class, and I'm going to store it inside of that TV remote variable. Because I know that the LG and the Sony remotes both implement iTV remote. That can be done using what's called reflection. I don't want to get too far down that rabbit trail. So let's do a simple implementation. And we'll take the DVD kind of out of the picture for the moment. So we'll do a console.readline. Our name equals, and then we'll say iTV remote, TV remote is fetch remote by name. And we'll generate a method for that. And then here we'll just use a simple switch statement. So if the case is an LG remote, actually what we'll be getting back, CW, pick by number. So we'll get the number back. So if the case is 1, return new LG remote. Case is 2, return new Sony remote. The default return null. So if you pick the wrong one, you don't get anything back. So the DVD remote is out of the question now. We don't need this line either. So basically what will happen is we'll get a prompt. We'll pick a number. This fetch remote will take that number, convert it dynamically for us to, it'll create the appropriate class type, and then it'll return it to us. So if we have 5, pick by number, so I want a 1, and it'll run the LG remote test. Run it again. 2. Sony remote test. So by using the interface, we didn't have to declare an LG variable, a Sony variable, and then rack those tests up over and over again. Instead, we said, one line of code, go fetch that remote type. And then we offloaded that work of figuring out whether it's an LG class or a Sony class or a Samsung class or whatever. We offloaded that to another method. But we knew that whatever we were getting back is part of that club. It's in that ITB remote club. So that we know what methods are on it and we know what actions we can take on it. The same philosophy for a database again. So let's kind of bring that back. So if all of a sudden we need to create a connection to a database, but we really don't care what type of database it is, as long as it implements that IDB connection, IDB command, IDB data reader kind of pattern, then we just say, get database connection. It returns us an IDB con object. We can call connection string. We can set the connection string. We can call open. We can even call create command, which will give us an IDB command. We can do all of that without ever knowing what type of database we're connecting to. So there was an application that I wrote in my former job. And it was built off this fundamental concept. I choose PowerPoint because it's easy to draw shapes. So the application had all these different databases that existed. And I needed to be able to connect to them. Rather, my users needed to. So up here was the user interface. What they wanted is they wanted the user interface to always be the same. They wanted it to be consistent. They didn't want it to be changing as these systems underneath changed. So these systems all held data. This is for a school district. So one had student data in it, one had student services information in it, one had parent data in it, one had test scores in it, one had grades in it, one had their Blackboard data in it. So this data was all over the place. All these different databases, different connection types, all this different stuff. I didn't want to have to worry about when they decided to pull out this system and replace it with another one, that I had to write the whole application over. I wanted it to be interchangeable parts. So if one day you're on Blackboard, the next day you're on Canvas, I don't care. One day you're using Gradebook A and then you decide to use Gradebook B, I don't want to have to care enough to go all the way back up to the UI to all of my event handlers and recode them. That's just time-consuming, monotonous, and unnecessary as far as I'm concerned. So instead, I started to look at this architecture and say, what can I do to make this easy? Well, the first thing I said was, there's always going to be this layer of student data. And in this layer, I'm always going to have things like student and the student object. Well, the student object may come out of different buckets, but it's always going to have the same basic things. First name, last name, student ID number, birth date, home phone, email, those types of basic mechanics, those basic properties. So I created an interface in this data layer. So now my UI, my form, my event handlers are no longer worrying about what kind of objects they're dealing with. They know that they're dealing with iStudent, iTeacher, iCourse, iSection. All these interface implementations of the data that actually live down here. So whether I'm pulling a course from the student schedule and pushing it up, or if I'm pulling a course from Blackboard and pushing it up. Courses always have a name, a course ID, those types of things. So this red layer is the student data layer. It's just those interfaces. On the flip side, I had system.data down here. So I would always use the system.data, the IDB connection, IDB command, IDB data reader, to pull the data from my database. So I'm trying to make this as agile as possible. So the one hook, the one piece that I was stuck with was, how do I get the data from the database into these interface? I need an object kind of underneath these interfaces, right? Because the interfaces themselves can't hold data. They're just blueprints. It says, hey, this is what the club looks like. So what I did is I did two things. I created one set of provider interfaces. And then I created kind of side by side provider implementations. So all my event handlers would say, okay, I need an iStudent and I need an iStudent provider to get me that data. But then I would have that dynamic piece that would say, I need to find something that implements iStudent provider that can give me back a student. So traditionally, when you guys write your code, you do a lot of, here's the event I'm handling, I need to go get data. I'm going to write that event, I'm then going to create a system.data.something database connection object in my button click. That's going to have some SQL in there, or it's going to call to my repository class, my utility class, which has this data in there, and then it connects to my database. I use those same mechanics, but instead, this is where all of my utility classes live, is in this provider implementation. And each one of my utility classes has an interface that mimics it. So what happens is, I'm no longer going down this path to get to my data. I'm going more down this path, but I have some voodoo, if you want to call it that, some black box logic that says, this is the interface of the utility class I'm looking for. I'm looking for one that implements iStudent. And what it does is it says, okay, I'm going to go look over here in this class library, and I'm going to find something that implements the iStudent provider, and then it gives me back that instance. Just like the fetch remote had that switch case and did that work, well, I had a fetch provider, and it would give me back the appropriate provider. So what this does is, when one of these databases gets removed, and it gets replaced with another kind of database, that's a terrible color option. All I have to do is come in alongside here and create another provider implementation that goes with it. And then that kind of in-between code says, okay, you're looking for parent data. Well, parent data uses this guy, and this guy knows how to talk to this database. So the idea is you're trying to make your application as flexible as possible by using this idea of like interchangeable parts, just like with a car. You have gears that plug into one another, but in order to do it, you have to create these blueprints to know what the shape of the gear needs to be, what the class needs to look like so that it can be part of the club. And then you use what's referred to as dependency injection containers to do this injection, to take these implementations and put them in your providers. Just like our fetch remote, this is doing that idea of dependency injection. It's doing the logic. It's trying to figure out for you how to take something and inject it and replace it somewhere else. I know I'm getting close to an hour and you're all starting to go, what? So doing this gives you that flexibility. It gives you this ability to kind of begin to, the term is decouple your application. So that all the necessities, all the things that your program has to do no longer reside inside of the one application, but are, again, these pieces that are all kind of plugged together. Okay. All right, so it's been an hour. I've rambled.